Okay, good afternoon, everyone. Hopefully everything is well. Welcome to a new episode of the Bisimoto Tech Tuesday. I'm here in the facility in the back of the office, and I'm surrounded by some beautiful specimens of automobiles as grinding happens on the side of me over here. Surrounded by magnificent vehicles. I have the Hot Wheels center seat here. I have the Bisimoto Veloster N 2020 there. I got the first Porsche I ever built in my life right there, the 850 IROC Porsche. I have a nice AMG convertible here as well, courtesy of our friends next door at Ruthless. And for those of you on YouTube, thank you for joining me here and allowing me to use YouTube as an archiving opportunity. So I appreciate all of you there. One thing I always missed on that car is converting to flex fuel, because I have this weird thing with my petrol cars. I have this weird guilt with them. So what I try and do is convert it to a fuel. Even though that's a pre-smog vehicle in California, I desire to convert it to a fuel that is less polluting to the atmosphere. So instead of having gasoline, which has gasoline and water methanol, I'm going to convert it to an ethanol monster. So that being said, it doesn't put as many pollutants in the atmosphere. I don't have to worry about the oxides of sulfur and oxides of nitrogen. And so there's something I promised to talk to you guys about. And Miles, you came at a perfect time. You want to find out what was up. So this is what we'll do. See this? It's a piece of pipe. It's like a large pipe that we use for exhaust systems on some of the turbo applications. Also on some NAs that are pretty high strung. And can't wait to see as well, Nate shoots. This is a file. So a file, pipe. And I'm gonna make a very obnoxious noise. Hello, Purell USA, good seeing you. I love you guys. I'm rocking the Purell hat right here. Boom, boom, boom. Okay, so, pipe, file, obnoxious noise. It's annoying, right? Well, that's what happens in your engine when you knock. Knock. Now, what happens, what is actually happening because it's knocking, is like your piston knocking against the sleeve. And what causes this knock? 2-liter mixture, a fuel that has reached its definite, anti-knock properties, so it just cannot burn properly, and you have this uncontrolled burn. And many times, when I've seen with customers coming in here with other tunes, too much ignition timing. Yes, pre-detonation, and that's what our good friend JX Nathan just mentioned, is when your pressure that occurs inside the engine itself is high enough to whereby it can ignite the fuel mixture. Or the fuel doesn't have the capability of having anti-knock, so it self-ignites. Or you have something glowing like a weird spark plug with the wrong heat range, or a piece of metal hanging in the middle of your combustion chamber, or something just very weird causes this pre-ignition detonation. Now, one thing that's pretty cool, and why am I talking about this to you guys? Because I see so many of you out there with engine management solutions that are not ideal. I see all these guys who try to skim on engine management solutions come to my facility, and my hands are tied. It's like me trying to do surgery as a physician with a butter knife. I can do it, but I can do a great job because I don't have this very important aspect available to me. And that is a knock sensor and being able to see knock in my ECU. So that being said, a knock sensor, as the name implies, is a sensor that determines knock. It's just a glorified microphone. And I, as a tuner, can look at this very nice chart that shows knock. So I can do sweeps where there's no knock and see where the noise level is for an engine naturally. And once I get to a threshold where knock starts to occur, it spikes and shows me that, and I can reduce timing and add fuel to that. But sometimes these cost-effective engine management solutions don't let us look at that. And that's very, 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 very bad. So what is the solution for all of us? Get an engine management that is good. This one runs an Infinity, that runs an AM Series 2. It allows us the capability for me to see knock per cylinder. And how does it do it? I don't need 4 microphones or 4 knock sensors to be able to look at every cylinder. Based upon the 720 degrees of rotation in an engine, I can determine, based upon the ignition window, which cylinder is knocking. And then, using the software, I have the ability, for example, the AM Infinity, to add fuel and remove timing based upon RPM, load, as well. And those are 2 very important aspects. JXN just asked about Hondata. Well, let's say I have a vehicle right now, the dyno, that is on Flash Pro. I can see knock per cylinder, very nice, right? But when I want to apply the necessary additions to remove knock, it's very challenging for me to do. What do I mean by that? That vehicle, there's an S2000 right now, the dyno, boosted on 91, made 470 horsepower, very nice, right? But something very interesting happens. The number 3 cylinder at 5,600 RPMs gets a little unhappy. Underneath that, it's happy. At 5,600, it has just a little, okay? And I don't like that. So I want to remove that. I want to take that away. It's not like this. It hasn't got there yet, but it's doing a little, okay? And see why I do this? It's just, it already messed up. Look how you broke it? That's what happens to your piston, okay? So this is a perfect analogy. Anyway, so here's what I had to do. Because I was tuning on a Flash Pro, I only have a global ability to remove timing per cylinder. So to make the customer safe, I removed 1 degree of timing for the entire cylinder for every RPM, even at idle. Now, what does that do? It puts me in a position now where that car, even though it's safer in the higher RPMs, I add a little bit of fuel, I took away 1 degree of timing, it now hurt power in the other regions because I optimized ignition timing below 5,600. So now my client has a little bit less power, which I don't like, for the sake of being able to control things up top and make it safe. Now, Golden Wolf 888 says, AM Infinity, standalone ECU, FTW, he's right. Because what I would do with Infinity, in the case like that, is I'll be able to determine, which I did, that at low RPMs, at low loads, there was no knock. So he'll have all the cruising power he wants at 5,600. When he's on the track, he's tracking, yeah, 5,600, letting off throttle in the corners, he's fine. And then, when boost kicks in, and it doesn't knock at 5 PSI, it doesn't knock at 10 PSI, is when we got a little bit closer to 9, 10, it started knocking. Then I can add a reduction of timing and add a little fuel in that region. So now he has all the power he needs and all the safety he needs, and it's great. How important your engineering background is to your success in the automotive industry? Immensely. So, let's talk about a few contributions that I have had the honor of participating in. Hey, Shell, good seeing you. Long time no see. Let's talk about some of the contributions I've done to this scene, just based upon me being an engineering student and eventually an engineer and putting that knowledge to the car world. Adapter plate kits. You know, those people running HTDs and HTBs came from here. And it's once again me trying to find a solution to a problem. The problem was I want to run a bigger engine than my D series, so the H22 or F22, and I wanted to keep my D series gearbox, which I invested quite heavily. I bought a Mugen final drive, and I didn't want to cut up my chassis. So I didn't want to cut up my chassis, I want to keep my gearbox. So my engineering background allowed me to solve that problem by developing an adapter plate kit and a custom flywheel that can offset that. Then I got knocked off if one copied it. Okay, header systems. I hated the fact that when I bought commercially available headers, when I drove around the streets, my header would hit a speed bump because my car slammed and I destroyed it. So I designed very, very efficient headers with multiple steps that allowed you to have the collector up front and just a single downpipe going underneath. So you don't have the capability of destroying your piping or your primary cylinders. Oh, I got knocked off there again, and of course, you know, I got out of the market. It was just crazy. People kept knocking me off. But that's another contribution I had. Then, ITBs. No one wanted to make ITBs in the volume size that I wanted. TWM didn't want to, so I went to Jim Kinsler. Jim Kinsler became a mentor of mine, knocked it off. We had some good engineering discussions with him and his team, Scott, and came out with the first Kinsler manifold, which I should really, next Tech Tuesday, I'll grab it. It's upstairs in my mezzanine. I'll grab the very first Honda Kinsler ever made. And now, everyone benefits from it. There's so many people who are drivers in ITB. Some of them talk crap to me too, not knowing that their ITB existed only because of my interaction with that. So what does that mean? Being a problem solver, that's the key element in engineering, and that allowed me to be able to apply that knowledge to what I do. When it came to intake manifold designs, exhaust manifold designs, all of my studies in fluid dynamics helped me design something that the manufacturers in turn were able to create for me. Above and beyond that, when you take a look at being able to look at a problem not as a challenge but as an opportunity, allowed me to have those adapter plate systems. And fast forward to today, we get to build cars like this, 2020 Veloster N, no tuning solution available for this. I didn't see any downpipes that were very designed well. Worked with AEM induction to do a very, very custom intake which everyone can benefit from. So answer is yes. Immensely, my engineering background allowed me, especially on the problem-solving side, to be able to become a better tuner and builder and designer in the automotive scene, you know? Golden Wolf says you made the path for better ITBs. Amen. Absolutely, especially with stage injection, because I remember having a discussion with Jim, and Jim Kins was in Troy, Michigan, and I said, hey, I have this concept where I remember in lab, I almost got kicked out of school for this, having an injector and pulling it away from the manifold, and notice that the farther away my injector was, the better the spray pattern. So I understood that having better atomization is dependent on the distance from the valve. So as long as I have control over my timing of the fuel, or let's say phasing, and I can pull it back, I'll make more power. And Jim said, absolutely not, BC, I will not make that manifold for you because you can create a fire situation. I mean, what do you mean? Well, during overlap with big cams, you have this opportunity where fire can come up the tract and the car can burn down. I said, yes, Jim, I know that. But I have a solution. Why not injectors in the front so you can keep the flame in the engine bay far, far down the tract as it's designed to keep it safe. And then in high RPMs, when you have no chance of reversion, introducing the secondary injection, I can do that with the AM EMS. He said, okay, if that's the case, no problem. So that being said, stage injection, which I gained, by the way, on my Insight right there, 20 wheel in stage injection came from that. Once again, me understanding fuels, me understanding the engineering behind camshaft designs and overlap and reversion, all that fun stuff. I had a good question that I just missed here, where someone asked about cylinders and which one is the most challenging. Firing order. 1, 3, 4, 2. Number 1 fires. Then number 3. And while number 3 is firing, number 1 now has time to cool down, right? But when number 3 fires, the next one that fires is 4, next to 3. And then after that, what else fires? Number 2. Number 3 doesn't get a break, does it? At all. 1, 3, 3 is hot, then 4 next to 3 fires, and 2 next to 3 fires, it never gets a chance to cool down. While the other cylinders in that cycle do have a chance. Number 1 gets to chill a little bit, 4 gets to chill a little bit, 2 gets to chill a little bit, right? So guess what? That being said, you notice, especially in that car, I just mentioned number 3 cylinder is always the hottest cylinder. So what I tend to do, off the bat when I tune, and this is a little tuning secret, right? Off the bat when I tune a car, and you see this also in your own car, AJ, I see you're here, I do tend to remove at least 1 degree of timing from number 3 cylinder and add a little bit of fuel, just to keep it safe, just to keep it a little happier. Can you make a nitrogen-cooled engine? You could, but that would be a bad idea. And why? Because of aluminum is what most of our internal combustion engines are made of, right? And aluminum has a very high coefficient of expansion. And you know what happens if you introduce nitrogen, which has a very low latent heat of vaporization, meaning it's very, very cool? If you introduce nitrogen, which is extremely cold, into a hot surface very easily, the expansion of the layers of aluminum in the hottest side may stay hot, and outside will expand even quicker, and it'll fracture. You know? Innocent says, where do you get all your cool car clothes? This right here is, you can see the B there, Bisimoto. It's on the Bisimoto web store. So if you go on bisimoto.com, on the apparel, most of the clothes I wear are from that, indeed. So if you like it, go ahead, you know? But, oh, JX, I got my degree at Cal State Long Beach. Thank you, Jermaine Cooper, appreciate that. I'm 15 and too poor to be able to call like y'all, says Dali, 12353. 1253, I should say. Don't be. When I was 15, I was hard in the books. It took me years to get to where I am today. But one thing that I can tell you, Dali, is to stay focused. If you want to build cars like this, don't think of yourself as a poor person. Think of yourself who's at the beginning of your journey. And really, I came to America with 2 suitcases. And I got picked up by a family at the LA airport. And I didn't have anything. And even though my parents helped me out a little bit, I actually called my father to his laughter and chagrin. And his laughter and my chagrin, I told him not to send me resources anymore. And I took it upon myself to fend for myself. And it was the worst and best thing for me to ever do. So I remember once I even bounced a check for $13 for my pager. I just couldn't, I didn't have $13 in my account to pay for a pager bill at the time. And that being said, it was really tough. But I stayed focused and persistent. I graduated, finally with my own resources. I was able to get my first job, and I kept racing, getting partners involved and designing components and really saving up to get the right parts, something I don't see nowadays, which is sad. I see so many people come here with cheap rubbish parts when they could have saved up and then done it right the first time. Now, what happens with cheap rubbish parts? The cheap rubbish parts break, they have problems, they now have to come back to me again to dyno after I give them the insight on what to fix, And now net, they spent more money. But if you do it right the first time, you just have the patience, it's perfect, and you can enjoy your project. And that's what allows me to be very successful in every facet of my life. Patience and persistence, you know? Lucas Westlenberg says, where should I start as a beginner tuner? First, find a car that's very tuner friendly to use as your little platform. That's what I did. I started with a CRX. And secondly, you want to take classes. Read all you can from reputable sources, or better yet, I know with COVID that was kind of strange, but look up EFI 101 or HP Academy. These are very reputable sites and outlets that can teach you the basics of tuning. And even if you're a seasoned tuner, like I was for many years, I still took those classes and I learned a lot more. And that allowed me the opportunity to understand very simple things like the auto cycle and what that means. What is fuel ratio? Well, how important is that? Why does every car have to be tuned differently? What's ideal fuel ratio for boost? Is there such a thing? Knock function and characteristics. Variable cam timing. All these things, closed loop feedback for boost, closed loop feedback for O2 sensing, feedback for knock sensing. You can learn all that and it's a great thing. It's almost like tuning for me is not really a great business. It's tied to my time and resources, but it's something I do because I really enjoy it. I enjoy tuning. It's like you're constantly solving an equation in real time. You're constantly looking at things real time, especially with dyno I have, and you're problem solving. I love that. I love that a lot. AJ, you love tuning. You really would, you know? Engine tuning versus chassis dyno tuning, AJ says. Great, man, these are some great questions today. I'm so excited. Okay, so here's what I discovered years ago. I'll tell you a little story, and then that will lead to answering AJ's question. Years ago, we didn't have access to ITBs, right? And they're talking about this like in the mid-90s, mid to late 90s, and I had to tune my cars and make a lot of power. And I learned from JC, the founder of AEM, that dual carbs allow me the opportunity on my inline four to make good power and get a lot of flow. So I take a dual carb engine, I tune it on the engine dyno. It's perfect, right? Because you can change things very easily on engine dyno. It's very conducive to change exhaust header lengths. It's very easy to change trumpets. You can be in a safe environment outside the engine room. You don't have to smell fumes. It's really cool. And it just looks really, really bitching, right? So I had the opportunity to tune it perfectly. Let's say I make 200 horsepower. Perfect, right? 200 horsepower to crank. Awesome. So if I put in my car with about a 17% drivetrain loss, I should make about 170, right? No problem. 170 wheel, great. I put in the car, start it, the car runs like crap. What happened? Not only am I not making the power, it is running like rubbish. How is this possible? Then it hit me. Engine bay dynamics. Inside the engine dyno is an open room, pretty much almost as large as this location, this area right here, in a very controlled environment with nice air coming into it, and then the trumpet length that you're experiencing, the wave harmonic that you're capturing with the traveling of the pulse wave down the tract of the throttle body goes down to the end of it and reflects. So you're tuning with a perfect length. You put it in the engine bay of your Civic, your CRX, your Nissan, your Toyota, you now have a firewall. The firewall now reflects those waves differently. So your tune is out the window. So what is my experience when it comes to engine dynos versus chassis dynos? Engine dynos are a great environment to be able to develop products. It's very easy. You can pull exhaust manifolds off, pull intake manifolds off, do clever things with camshafts. It's very conducive to do testing in a controlled environment, which is great. Many advanced ones have the ability to control the temperature in the room, which is great, and have a very good exhaust system, so you don't have any kind of rubbish or you're not ingesting any contaminants or combustive elements. The natural bay of the engine is the natural habitat for the engine. So if you're going to do something, even with race teams, it's good to be able to test it in a chassis, especially if you have challenges with ITBs, your firewall, or you have to change piping around due to your turbo system, or better yet, you can diagnose things like your axles misbehaving or gearboxes and so on and so forth. You can really do a lot of diagnosis on the dyno. It's one of the reasons why I invested heavily in a dyno pack, even though it's extremely expensive. The dyno pack is the closest thing to an engine dyno, AJ, from Relentless Racing, with the engine existing in its natural habitat. So why is it very similar? I don't have any tire interface that can skew results. Most customers come here with their race cars not even aligned, so it won't mess those things up. I don't have to worry about strapping. I don't have to worry about weird results because of what gear I'm in, because on the dyno pack, no matter what gear I'm in, because of the torque multiplication that you put in there, it gives me the same number. While with a dyno jet, when you use gears that have more mechanical leverage, it gives you more power output. Because guess what? How does it calculate the power? By how easy it is for you to overcome the resistance of that large flywheel in the ground being that big roller. So if you can overcome that easier, you make more power, right? Well, you can do that with gearing. And plus, it's very quiet, so I can even hear things, and I can look real time as I'm doing dyno tuning. I can look real time at keeping a fixed RPM and varying my throttle, and I can see each axle output. If one is putting out more than the other, I can something's up one of my axles, I can tell. It's really good. It's really good, you know? Can you balance the heat and nitrogen-cooled engine? The heat and nitrogen, yes, you can. So you could mix two things to be able to cool it, but it's, one thing is, as an engineer, and AJ, I know you can back me up on this one, I'm big on engineering economics. So what does that mean? Because you can do something doesn't mean it should be done, because it could be ridiculously expensive. Now, I'll give you an analogy, just to go along the lines of what your heat and nitrogen-cooled engine is, right? Let's say I want to travel to AJ's house. I have two options. AJ lives in Long Beach area. Hope you're safe over there in Long Beach, by the way, AJ. I can drive my electric car to AJ's place and see him and drive back, or I can build an airport here, pay AJ to build me an airport there, buy a plane, and fly to see AJ. Which is more expensive and which is more cumbersome? Of course, the latter. So, with what we have today, with water being a very efficient cooling mechanism, and water pumps and the vanes that we have now being mechanically driven by the motor itself is a very efficient way of doing it and very cost effective. It is a very good solution to use that, and even to some extent, air cooling, to be able to cool an engine, then try and mix heat from an engine or source and nitrogen from a source that needs to be replenished to be able to perform the same function. So I hope that makes sense, you know? What do you need to study to work on EVs? I would say a very good understanding of electrical engineering. Or there are actually, if you want to be able to get on the service side of it instead of design, you could go to local colleges. They have courses in renewable energy. I know that near me there's Rio Hondo College and they have that. They literally have a course dedicated to this, and companies like Tesla and BMW are picking those people up like crazy when they graduate. And there are small classes of like 30 to 40, which is very nice, so you could do that. It depends on what facet of the EV. Have you ever done a fine-tuning as a passenger on the move, meaning while driving in real conditions, says Peter Pattis? No, I don't do that for two reasons. One, it is dangerous. Street tuning is very dangerous. Even if you're trying to move, you're trying to play with keys, it's just so dangerous. I will confess that I have had the opportunity to do two situations where I had to either sit with someone or log something and make some changes. And that was very brief periods of time. I say extremely brief. One is this. Supra. Toyota Supras make great power. 4th gen, the Mark IV. Great cars. You can tune them, make tons of power with the factory engine. You build them, you put camshafts, you're a superhero, it's great. And my dyno does a great job in being able to keep things at steady state. So I can lock the Supra at 1500 RPMs, vary my throttle, and tune, and impeccably tune to partial throttle. That's why I don't have to drive it anymore, because I can impeccably tune partial throttle. I can do it throughout the entire RPM range. I can go up to 6,000 RPMs, lock the car at 6,000 RPMs, vary throttle to 100%, and tune each cell if I wanted to. So it's great. And that's what some tuners trying to achieve. Either they're being cheap and going with a street tune, which is horrible, by the way, because you cannot optimize anything. You can't. You cannot optimize ignition timing or cam timing on a road driving around. You just don't know if you're going the right direction. You don't know. Or someone has a dyno jet or inertia-based dyno where you cannot limit RPM and tune a particular RPM range to make it perfect like the OEMs do. When Hyundai builds this car and they do mapping with the Bosch ECU, they use a dyno pack to do it. Same with Toyota, same with Porsche, same with Honda. Toyota even uses ours sometimes. TRD here in the South Bay, when they're booked, they come here to use ours. So that being said, that's what they use, so I don't have to do that. So with the Supra, the only time I had to is moving from a stop. So The vehicle is perfect at AFR at idle, perfect AFR at, let's say, 1500 RPM, but when you're moving from 0 to 1500 and the super being very heavy, it may dip into regions that I couldn't see on the dyno. So that being said, I simply could sit with a client and have him just take off and stop. Literally 1 to 2 miles an hour, 1 to 2 and stop. And I log it, oh, okay, I see, too much fuel. Take away, do it again, oh, okay, the tipping fuel is a little bit too much. Okay, I take that away, and that's it. Second situation is, customer comes here, Air Atom, lightweight car, little over 1,000 pounds, makes 400 horsepower. When the gentleman drives away, car lunges. Why? As he's doing and he's lunging, his foot is also making it lunge worse. What was happening is the car is so light and the car makes so much power that when you tip into 5% throttle and the throttle body opens 5%, it wants the car to just launch. So with drive-by-wire, another great advantage of drive-by-wire, I had to, based upon the log and seeing what was going on, limit the amount of throttle plate opening versus pedal on the foot. So at 5% throttle, the throttle opened 2%. At 10% throttle, the plate opened, or the pedal, the plate opened 5%. At 20% pedal, the throttle body barely opened a little bit over 11%. And now the customer was able to drive, oh, I'm ready for the track now, he said. So that is the advantage. And that's the only other time that I would not even sit with a customer, but put my laptop on, have them drive it and log it. I never, ever, ever sit with someone. It is dangerous. Absolutely. I do need to see. Do you find a large portion of your success is due to networking and partnerships? What was it like starting out without the network? I would say the success that I had initially was really singular because I didn't have any support. So remember, I talked about this by last Tech Tuesday, and if you haven't seen it, it's archived on my YouTube page. When I first started, I didn't get any help. And as a matter of fact, Tim, TW, who's here, his best friend, John Concialdi, who took me on his wing and showed me the ropes. But at first, no one wanted to help me at all. So it was very, very difficult for me to get anything done. And even though I wanted sponsors and I begged for partners to sponsor me, companies to sponsor me, and there are 2 companies that were adamant in rejecting me and said really bad things to me that still holds a little bit of grudge to today with the team, I just couldn't get any help. So I had to go fast by myself. I had to buy components, experiment myself, because once again, I came from an era where you couldn't buy parts, right? You couldn't go to Amazon or Bisimoto and just buy parts and put in your car. You had to kind of create your own thing. And my success came from me experiencing a lot of failure, blowing a lot of things up, learning from that, not giving up and keep pushing on. I see customers or people at the track where they heard something like, oh, I'm done, I'm selling everything. I never gave up. I blow things up and I start laughing. You guys saw the stubs I posted, the 935 stubs I posted a couple of weeks ago? I had a guy from media in the car and he was shocked that I wasn't pissed. I was like excited. He's like, why are you excited? You're weird. And I told him I'm gonna learn something from this. So that was my success early on, was me being persistent and experimenting and trying things out. Fast forward to today, the reason why I can build great cars like this 2020 Veloster N here next to me is because of my networking with partners like the higher ups and property, I would say that, product planning at Hyundai. When it comes to the EV world, I saw a little bit of mixture of things. I saw some people who were willing to assist and some people who were like very standoffish, or people who embraced, and when they saw us, we were already like, oh no. Same thing there. I mean, being able to network and talk to people and interact is helping me along. But my initial success came from just hustling, really just working hard and making things happen, you know? You never know, you know? Jay Can, how's my day going? My day is going extremely well, thank you so much. NJ Obiala asked me a good question. What car did you learn to drive in and what you learned stick in a different car? What was it? Great question. I'll answer both at the same time, and I may have to fly. The first car that I learned how to drive in, and it happened to be a manual, was a Peugeot 504. Now, back home where I'm from, I never had the opportunity to drive a car because my family had drivers. So if you want to go somewhere, you tell the driver, they take you there. But as a curious engineer to be in my pre-teens, I always watched what my driver was doing. So I watched how he would put it in gear and then take his foot off the clutch and at the same time initiate the petrol level, right? The gas pedal, and then ease his way up. Well, when my parents would be at work and they left one of our cars at home, the Peugeot, I would start it up and practice in our compound. We had a pretty large compound, so I would drive around the compound and then practice driving the car. And I kept driving it, and then one day when I was bored, when my parents were gone, I went out the main road. I opened the gate and went out the main road. and came back in. And by the way, I was 12 when I was doing this, right? And I remember my father caught me once, and I said, Dad, I'm so sorry, I'll get a license. But you couldn't get a license until you were 16. So I went to the local DMV, bribed them, and got my license at 13. And what I'll do, I'll remember this, I still have my license. My next Tech Tuesday, or maybe I'll do it on a story, I'll put my next Tech Tuesday, I'll bring my original license when I was 13 here, and you guys will see my driver's license. It looks like a passport, but I was 13 years old with my driver's license that I bribed an official back home to get. Thank you so much for participating in this great Tech Tuesday. I had a blast interacting with all of you, my family. I look forward to really interacting more. I'll have this up here on Instagram in my permanent archive. Let's say I'll put it up as IGTV. And then I'm going to upload it to you guys on YouTube. And also, right now, as you can see, I'm recording with this phone a podcast. So if you like to listen to this on your favorite podcast networks, you can do that on Anchor or Spotify or Radio Public or Podbean or Apple Podcasts or Google Podcasts, whatever your favorite one is, okay? So thank you so much, guys. Have a great afternoon. Stay safe. Stay woke. I see all this great stuff here. And I will talk to you guys soon. Cheers. Bye.